This lesson is on electrochemistry. We start off with redox. Electrochemistry involves the study of movement of electrons from one chemical species to another. A redox reaction is a reaction involving the transfer of electrons. Transfer meaning the movement. So electrons transfer from one species to another chemical species. There are two simultaneous reactions that occur in a redox reaction. The first is the oxidation reaction, and the second is the reduction reaction. These reactions need to occur simultaneously in order for the redox reaction to take place. Since we are dealing with a redox reaction and knowing that it's the transfer of electrons, we need to know which reaction, either oxidation or reduction, is the gain or loss of reactions. In the first reaction, oxidation, it is the loss of electrons. It's easy to remember that because you can remember oil, O-I-L, for oxidation is loss. Oxidation is the loss of electrons. Reduction is gain, rig. The reduction reaction involves the gain of electrons. So the little side note to help you remember, oil, rig, oxidation is loss, reduction is gain. Ions are formed from the loss or gain of reactions. Ions are charged particles, basically. So they are particles that have either gained or lost electrons, and therefore have either a positive or negative charge. Okay, atoms or molecules, these are neutral particles. Same number of protons and electrons. Whereas ions are charged particles. So they either have an excess or deficiency of electrons. So going back to what I said, they either have a positive charge because they've lost electrons, so they therefore have more protons than electrons, or they are negatively charged because they have gained electrons and therefore have more electrons than protons. So that's important to remember the difference between atoms and molecules and ions. So atoms and molecules are neutral particles. Ions are charged particles. Okay. Then we move on to oxidation numbers. Oxidation numbers identify which species are being reduced or oxidized. Okay. An atom or molecule will have the sum of their oxidation numbers is 0. So 0 now represents the charge. It has got a 0 charge. It is a neutral particle. Whereas an ion, their sum of oxidation numbers is the charge on the ion. So it'll either have positive or negative a number. If it has a positive number, if it has like +2, for example, as its oxidation number, that means that it lost electrons because it started off as neutral at 0 and then it went to positive. So that means that it lost electrons because there are more protons now. If you had a negative ion, that means that their oxidation number is negative because it gained more electrons, making what was neutral now negative. Okay. So now, in order to see the different types of oxidation numbers that there are, okay, all elements in the natural form, so pure elements or diatomic elements, for example, O2, they have an oxidation number of 0. Okay. Hydrogen, this is when we have hydrogen by itself. So this is not diatomic hydrogen, it's just one hydrogen atom. Then you generally have +1 as your oxidation number. The only exception is when it's bonded to a metal, it will have -1, majority of the time. hydrogen will have +1 as its oxidation number. Now we move on to oxygen. Oxygen is normally diatomic. When it is not diatomic and it's by itself, it will have -2 as its oxidation number. So we're talking about just a single O. Okay, this is again an exception. In peroxides like H2O2, where it is -1. And when it is bonded to fluorine, it is +2. So these are the two exceptions. When oxygen is in H2O2 or any other peroxides, it'll have a oxidation number of -1. And when it's bonded to fluorine, it'll have +2. But most of the time, and in general cases, it will have -2 as its oxidation number. Then we move on to group 17. They have -1 as their oxidation number. Group 1 metals have +1 as their oxidation number. Group 2 metals have +2 as their oxidation number. Group 3 metals have +3 as their oxidation number. Then monoatomic ions. For example, zinc 2+. This the same as the charge. So for zinc, here it is +2. So the oxidation number, if you have a monoatomic ion, the oxidation number is the same as the charge. So +2, therefore oxidation number, well, the charge is 2+, the oxidation number is +2. Then we move on to transition metals. This is indicated by the stock notation. So stock notation is when you have these brackets after a metal and it has a Roman numeral number. So over here, this Roman numeral is 3. So therefore, its oxidation number is +3. There are different metals that will have different Roman numerals, and that will tell you what their oxidation number is. In a neutral compound, the sum of the oxidation numbers is 0. We have mentioned this earlier. Neutral compound being atoms and molecules, they'll have their sum of their oxidation numbers will be 0. In a polyatomic ion, the sum of the oxidation numbers is equal to the charge of the ion. Okay. This is a very complicated wording, but it basically means with ions, if you take the sum of their oxidation numbers, that will give you what the ion's charge is. So the charge is equal to the oxidation number. Let's go through a few examples so that we can see. Okay, so here we have H2SO4, sulfuric acid. Okay, we want to figure out what sulfur's oxidation number is. So what we know it's neutral because there is no charge at the top, meaning that the charge technically is 0. So we know that hydrogen has a charge of +1. There are 2 hydrogens, so we multiply it by 2. We then add what we don't know, sulfur, which is X, plus oxygen is -2. We times it by 4 because there are 4 oxygens, and we make that equal to 0 because we know that the sum of the oxidation numbers is 0 in a neutral compound, and we are dealing with a neutral compound. So we have taken the sum of the oxidation numbers and made it equal to 0 to solve for the unknown oxidation number. So once we simplify, that will give us 2 plus x minus 8 equals 0. We take the 8 to the other side and the 2 to the other side. It becomes 8 minus 2, which gives x equals 6. Therefore, sulfur's oxidation number is +6. Then we move on to K2Cr2O7. Okay, we are wanting to know what Cr's oxidation number is. We're going to now call it X. We can see that this is a neutral compound because there's no charge. So we know that it's going to be equal to 0. K has an oxidation number of 1. So it's going to be K times 2 because there are 2 potassiums. So K times 2. Chromium or Cr2 is going to be labeled X because we don't know what its oxidation number is. Then we have oxygen, 7 oxygens. We know that oxygen is -2, so -2 times 7. We're making these all equal to 0. This will then simplify to 2 plus x minus 14 equals 0. Then we do some algebra and we get that x equals 12. However, x is not Cr. Cr2 is x. So we're going to replace x with Cr2, which is 12. Therefore, Cr has an oxidation number of 6. It's important to remember that if you are substituting Cr with if there's 2 of them, and you've substituted with just x, you must remember that when you're subbing Cr back into x, you must write it as Cr2. Then you can get the oxidation number of just Cr. We then move on to NaMnO4. Na has a bond number of 1. There's only 1 of them, so it's just 1. Mn, we don't know. We're writing it as X. Then O is -2. We're timesing it by 4 because there are 4 oxygens. It is a neutral compound, so therefore we make it equal to 0. We simplify. We're going to have 1 plus x minus 8 equals 0. Therefore, x equals 7. Therefore, Mn, manganese, will equal plus 7. Manganese's oxidation number would be plus 7. Then over here, we have PO4 with a charge 3 minus. Okay, now this is not a neutral compound because it has a negative charge. So we have a polyatomic ion. So we're going, and the sum of the oxidation numbers is equal to the charge. So we're going to have the oxidation number of P is what we don't know. That is going to be labeled X. Oxygen is -2. We have 4 oxygens, so -2 times 4. It's going to equal to -3 because that is the charge. We're then going to solve for X. X minus 8 equals -3. Therefore, X equals 5. Therefore, the oxidation number of phosphorus will equal +5. Now we're going to look at oxidation numbers in reactions. So over here, we have 2Mg plus O2 to give 2MgO. Now, we're going to write the oxidation numbers above each element or atom, whichever. So Mg is starting off as 0 here because Mg is the whole molecule. So that is, and it's got a charge of 0. So its oxidation number is 0. Oxygen or O2 also has a charge of 0, therefore will be 0. Over here, we know that oxygen, when bonded, has an oxidation number of -2. So we're then going to have -2 over here. In order to get this to be neutral, Mg would have to equal +2. If you want to, you can go use the method we've used just now when solving for x to figure out that Mg is equal to +2. But it's basically x minus 2 will equal 0. Therefore, x equals 2. Okay, just a side note to remember, O2 over here, that is the diatomic of oxygen, diatomic molecule. The whole molecule has a charge of 0. That is why it's 0 over here. In this case, oxygen is bonded to magnesium and therefore has -2. So it's important to remember the difference. Okay. Now we're going to look at each element. Mg on this side changed to become Mg2+, which we worked out was the oxidation number here. The oxidation number changed from 0 to 2+. That means that it became more positive. It became more positive by losing electrons. It was therefore oxidized because oxidation is loss. Then we move on to oxygen over here on the left was 0, and it changed to be O2-. It was reduced. It gained electrons. It became more negative. Reduction is gain. Therefore, Mg became Mg2 plus 2 electrons, oxidation. It's important to show the electrons that were taken off of it, which is over here. However, O2 gained 4 electrons because there are 2 molecules of this MgO, so therefore there were 2 oxygens. So in order for it to be balanced, we have to have O2 to gain 4 electrons because each oxygen atom became 2-. That is the reduction. This is the oxidation half reaction, and this is the reduction half reaction. When they say half reaction, they mean this. You take the part of the main reaction out. So over here, this is oxidation half reaction, reduction half reaction. Okay, then just a little side note, if they were to ask what is the oxidizing agent, the oxidizing agent is the substance that accepts electrons or the substance that was reduced. So it's kind of an easy way to remember it, it's the opposite. So the oxidizing agent is the one that was reduced. The reducing agent is the one that was oxidized. In more technical terms, the reducing agent is the substance that donates electrons. And that is all for part 1. In part 2, we'll move on to the galvanic cell.